Good afternoon, all of you. My name is Shravani. I came from APTWREIS school, Rajavommangi, East Godavari district. Today I teach about a new topic. First of all, I ask some questions. Friends, what is this? Yes, this is SAPNET. Friends, what is this? Yes, this is soap. What is the taste of it? Yes, this is a bitter in taste. Friends, what is this? Friends, what is this? Yes, this is a tamarind. What is the taste of that? Yes, it is a sour in taste. Today we discuss about acids and bases. Our lesson name is acids and bases. The substance which taste is in sour are called acids. The substance which taste is in bitter are called bases. Friends, our lesson name is acids and bases. First of all, acids. The name of acids comes from Latin word which means acidus, which means sour in taste. For example, we take lemon juice. It tastes sour because it contains citric acid. Another substance we take milk. It also sour because it spoils, lactic acid is formed. We take another substance, meat or butter. These substances can be attributed compounds such as butyric acid is formed. Which acid, friends? Butyric acid. These three substances are sour in taste. Already we discussed. The substance which taste is in sour are called acids. Acids are sour in taste. Acids have corrosive. Acids change the color of litmus, certain vegetable dyes, blue to red. Look at this. Litmuses are two types. One is the blue litmus, another one is red litmus. We take blue litmus. This is the hydrochloric acid. This is the hydrochloric acid. We take some amount of acid. Slowly we take. We take hydrochloric acid and slowly added on blue litmus. Friends, observe. Look at this. Blue litmus turns red litmus in acids. Okay? This is the indicator. This is the indicator, methyl orange. We take methyl orange slowly added on hydrochloric acid. Slowly added. Observe, friends. I am slowly added. What is observed? Change the color. In acids, methyl orange slowly added, Then we observe change the color. We take some acid, some amount of acid. Next indicator, this is the phenolphthalein. Observe, in acids, slowly phenolphthalein is added, no change, colorless. This is the acid. Next one is base. Base, another name was alkali. Alkali as substance to consumed or neutralize the acid. Acid lost their characteristics, sour taste and dissolved when the metal is combined with an acid. Eventually, acids change the color of litmus comes when contact with acids. Eventually, alkalis became known as base for making certain salt. Alkalis feel slippery. Alkalis change the color of blue litmus turns red. This is the sodium hydroxide. We take sodium hydroxide. This is the sodium hydroxide. Look at this. Red litmus turns blue in bases. We take methyl orange, slowly added on base. Observe, it changes the yellow color in bases. We take methyl orange, slowly added the base, it turns yellow color. We take sodium hydroxide and dilute the water. And we mixed phenolphthalein. Look at this. We added phenolphthalein and sodium hydroxide changed the color of pink. It is a beautiful, nice color. In bases. Next topic was pH. pH. What is meant by pH? pH means, P means power, H means hydrogen. P means power, H means hydrogen. pH scale was used by Danish biochemist. This is proposed by Sorensen. Who is friends? Sorensen. In 1924. To represent the moral hydrogen ion concentration and will evaluate in per liter to aqueous solution. Because of uncertainty, physical significance of moral hydrogen ion concentration, the pH definition of operationally the measurement of method. The national US standards has definition of term electromotive forces. Electromotive forces exciting between standards electrodes in specified solutions. The definition of pH is the unit of measurement for determining acidity and alkalinity of the solution. We know friends, the mathematical definition of pH, negative logarithm moral hydrogen ion concentration. This is the mathematical definition of pH and also chemical symbol of pH. The pH measurement requires periodic to maintain accuracy. This is the pH. Friends, how many values here? Yes, 14 values here. Friends, less than 7 is acids, greater than 7 is bases. 7 is the neutral compounds. For example, we take citric acid. It contains lemon juice. The value of citric acid is 2. This is the pH scale. We know Arrhenius theory by suggesting acids. Acids are neutral compounds. It dissociates in water to give hydrogen ion. In acids. In bases, it dissociates in water to give hydroxide ions. We take hydrochloric acid is an acid. It dissolved in water to give two ions. One is the hydrogen ion, another one is chloride ion. Look at this. We take water. In water, we take hydrochloric acid. They give two ions. One is the hydrogen ion, another one is chloride ion. In acids. In bases, we take sodium hydroxide is an base. It also gives two ions. One is the hydroxide ion and another one is sodium ion. In bases, any substance therefore any substance to give hydrogen ion when it is dissolved in water. Any substance to give hydroxide ion when it is dissolved in water. This is the Arrhenius theory. This theory proposed by Arrhenius. Next topic was neutralization. Friends, we know properties of acids and properties of bases. Look at this. Properties of acids and bases. Acids have sour in taste and bases Bases have bitter in taste. Don't feel slippery in acids. pH value of slippery less than 7 is the acids. Release hydrogen ions in aqueous solution. React with metals to produce a compound and hydrogen gas. Turns blue litmus in red. Bases. Bases have bitter in taste. Bases feel slippery. In pH value greater than 7 are acids. Release hydroxide ion in aqueous solution. Don't corrode metals. Don't react with any metal to produce compound and hydrogen gas. Red litmus turns blue. This is the properties of acids and properties of bases. Next one is neutralization. Neutralization. What is meant by neutralization reaction? The reaction of an acidity and base is called neutralization reaction. At the same time, the acid is neutralized by alkali. At the same time, the alkalinity of the alkali is neutralized by acid. We know, friends, product of neutralization reaction. Look at this. This is the product of neutralization reaction. Acid reacts alkali, then we get salt and water. I write two examples. We take hydrochloric acid and sodium hydroxide. Then we get sodium chloride and water. This is the acid and this is the base. Acid reacts base, then we get salt and water. I write next example. We take again hydrochloric acid and sodium carbonate. It also gives sodium chloride and water. This is the product of neutralization reaction. This is the examples of neutralization reaction. Understand, friends? Next one. What happened in neutralization reaction? Acid solution contains hydrogen ion. Contains hydrogen ions. Alkali solution contains hydroxide ions. Acid solution contains hydrogen ion. Alkali solution contains hydroxide ion. We take one test tube. And we take sodium hydroxide. Sodium hydroxide is the base. And we take water. We take another test tube and slow an amount of HCl, hydrochloric acid, slowly. This is the sodium hydroxide, and again I will add it phenolphthalein. It turns pink color. Look at this. This is the hydrochloric acid. This is the sodium hydroxide. Sodium hydroxide is an base. Hydrochloric is an acid. And slowly added to base. Look at this. This is the neutralization reaction. We take hydrochloric acid and sodium hydroxide. When slowly hydrochloric acid is added to sodium hydroxide, then we get neutralization. This is the neutralization reaction. This is the neutralization reaction. The acid is added to, the alkali is added to acid, neutralize it, hydroxide ion, which combines hydrogen ion each other out, a water molecule is formed. Look at this. This is the hydrogen ion. This is the hydroxide ion. Then we get a water molecule is formed. The above ionic equation shows what happened in neutralization reaction. Next one is neutralization in our daily lives. Neutralization in our daily lives. Scientific facts. Neutralization is various fields in our daily lives. First one is agriculture. Second one is health. Third one is industries. Fourth one is at home. These are the neutralization in our daily lives. Agriculture, it have two types. First one, to treat acidic soil. To treat acidic soil. Second one, to treat basic soil. Friends, I ask one question. The soil have acidic nature. What precautions we take? What type of precautions we take? Yes, we use basic fertilizers. The soil have basic nature, then we use acidic fertilizers to treat acidic soil. Plants cannot grow well in acidic soil. Next one, to treat basic soil. Basic soil can be treated by using decomposition of rotting vegetables and leaves. This is because of rotting vegetables and leaves to liberated carbon dioxide. Which gas? Carbon dioxide. This is the neutralization in agriculture. Next one, neutralization in health. Friends, have you ever faced gastric problem or acidic problem? What type of medicine we take? Yes, antacids. Antacids are medicine of containing bases such as aluminum hydroxide. Aluminum hydroxide and magnesium hydroxide. To neutralize the excess gas in our stomach. This is the gastric, this is the neutralization in gastric. Next one, bee stings. Bee stings are acidic in nature. To neutralize the alkali medicine and baking powder. Next one, industries. Industries, two types. To effluents and to acidic gas. Effluents. Friends, effluents have what type of gas? Yes, effluents have electroplating industry containing such as sulfuric acid. Which acid? This is the sulfuric acid. This is the effluents. By adding lime to neutralize it before it discharges into rivers and streams. This is the effluents. Another one is acidic gas. Acidic gas, energy industries, power stations, burning fossil fuel to liberated coal as produced. Burning fossil fuel to liberated sulfuric dioxide. Which gas, friends? Sulfuric dioxide. This gas is pollutant in the air. This is the neutralization in industry. Another one is last one, neutralization at home. Have you ever observed the toothpaste? Why are you during brushing every day? Yes, toothpaste. At home, two types, tooth decay and baking powder. Tooth decay. Decaying food particles produce acid and causes tooth decay. During brushing, help to neutralize the acid. Since tooth decay prevented the tooth decay. Tooth decay is alkali. Another one is baking powder. The formula of baking powder. This is the formula of baking powder. It contains sodium hydrogen carbonate. This another name was sodium bicarbonate. It is a weak acid. When water is added, both water and hydrogen reacts. The reaction like act on acid on carbonate. The reaction gives out carbon dioxide. This is the neutralization at home. Today we discuss about what is acid and what is base. Today we discuss about acids and bases. What is acid? What is base? Acid. Acids change the color of litmus blue to red. Acids have corrosive. Acids sour in taste. Base. What is base? Bases have bitter in taste. Bases feel slippery. Bases change the color of litmus, red litmus to blue. This is the bases, and we discussed properties of acids and properties of bases. Next topic, pH. What is pH? What is meant by pH? pH is the measurement for determining acidity and of the solution. Next one, neutralization. What is neutralization? Yes, the acidity of the alkalinity is called neutralization reaction. Neutralization reaction in our home, baking powder, toothpaste, these are the neutralization in at home. Next one, neutralization in agriculture, industries, health. Today we discuss about acids and bases. Our lesson is completed. Thanks for Secretary Sir for giving golden opportunity, and thanks for my principal madam and my guide. We are supported me so much.